Hi there, welcome to section 4.2. I know this feels a little weird since we already did section 4.3, but I like to do this in this order. I disagree with how the book set it up. So we're going to talk about slope-intercept form. We graphed in section 4.1 using slope-intercept form. So our objective is to write an equation of a line when we have information. And then we're going to write that equation of the line in different forms. So we did standard form. We talked about point slope in section 4.3. Now we're going to kind of work between all of them. So to write an equation of a line, we're going to identify or find the slope. Either count it on a graph, rise over run, use the formula, change in y over change in x, kind of whatever works best for you. We are going to go to the point slope form. That's going to be our go-to method. So y minus y1 equals m times distributed x minus x1. So kind of important. That's always going to be our starting place. There's other ways to do this, but this is the easiest way to begin. We're going to substitute the slope and the given point into that equation, just like we did in section 4.3. And then we're going to look for what form the answer should be in. We're going to distribute, we're going to solve, we're going to move things around as necessary. So everybody knows point slope form. That's the starting point. We're always going to use that. That's why I put that in that first box. Slope intercept form requires us to distribute and solve for y. Standard form requires us to distribute from that point slope, but then to get all the x's and y's on one side, all the variables together, and all the numbers together. So we've got a few things to do here in order to make this happen. So let's do an example. Example number 1, it says to write an equation in point slope form, we're going to do one of each, that passes through negative 4, 2 and has a slope of 3. So I know some information here, right? I know that m equals 3. I know that my point is negative 4, 2. And I know that's an x and a y, 1 and 1. So it said when we did those steps to guide us through, identify or find slope, well, we know that. Use our point slope form. And plug those things in. So I'm going to do y minus 2 equals a slope of 3 times x minus negative 4. And my work here is done because it told me that I wanted point slope form, so I don't have to go any further. So let's do an example that requires us to go further. So let's skip number 2 and let's do number 3. This time it says to write an equation in standard form. A line that passes through 8, 2 and has a slope of negative 3/4. So I know I can identify the slope as negative 3/4. Notice I put the negative up on the 3. I know I've got a point of 8, 2. And I know I'm going to always start off with this equation. So exactly what we did in that last problem, only now we're going to go further with it. So let's substitute this stuff in here. So y minus 2 equals the slope x minus x1, which is 8. Watch the signs again. That's really the biggest thing to be careful about. So now we're not done, right? It told us in step 4, look for what form the answer should be in. We know that we want all the x's and y's on one side, numbers on the other. Distribute if necessary. Distributing is necessary. So we're going to distribute this stuff. So the y minus 2 stays the same. Negative 3/4 times x is negative 3/4 x. Negative 3/4 times a negative 8 becomes a positive. I'm pretty sure it's 6. So now that I've gotten rid of my parentheses, now I can start thinking about things. We've got 2 things to deal with. One is fractions, because remember we don't have fractions in standard form. The other is not all my x's and y's are on one side of the equation. So we can take care of this however we want to. Usually people like to get rid of the fractions first. So my denominator in this problem is 4, which means I'm going to multiply and distribute both sides by 4. So on the left, when I distribute the 4 to the y minus 2, I get 4y minus 8. On the right, when I distribute the 4 to the negative 3/4 x plus 6, I end up with negative 3x plus 24. So that was taking care of fractions. Get rid of fractions. Now I need to put it in standard form. So now I want all my numbers over on one side, all my variables over on the other. Since that minus 3x is a negative, I think it would be easiest to add 3x to both sides of the equation. Put that line down the middle if you like. Remember, we're doing inverse operations when we've got an equation. So when I add 3x, those guys cross out. All I have on the right is a 24. On this side, I've got 3x, a positive 4y, and I still have that minus 8 because I didn't do anything with that. So now I'm going to have to get that 8, plain old number, sitting over there with the variables. So I'm going to have to add. And remember, the whole point is these guys cross out. So I've got a 3x plus 4y left on the left. And I've got a 32 when I do that math. There's my standard form equation. 3x plus 4y equals 32. So this is about a couple of things. This is about using point slope. This is about recognizing standard form, getting it into standard form with everything, variables together, and no fractions. So those ones are probably the ones that people struggle with the most because there is a lot of work required, but we did write that equation in standard form. All right, let's do number 4. Sneaky problems right here. You might even want to make a note. These sneaky problems, first of all, it tells you to write an equation in slope-intercept form. So hopefully you remember that y equals mx plus b is slope-intercept form. Notice it only gives us 2 points, a 1, 2, and a 3, negative 2. What is the number one thing on our to-do list in order to find the equation of a line? Identify or find slope. If I give you 2 ordered pairs, can you find slope? Absolutely, right? You're going to subtract the y's over subtract the x's. So we just have more work to do in this problem than we did in the last ones where I told you the slope. So if I set up my slope equation, negative 2 minus 2, 3 minus 1, that's not a 0 on the numerator. Negative 4 over 2. When I simplify, I'm going to say that my slope is negative 2. So now I've got my slope. Now I'm going to use my point slope form. Y minus y1 equals m, x minus x1, and I'm going to put those things in there. But I have 2 points, right? I've got 1 point up here labeled x1, y1. I've got 1 point up here labeled x2, y2. Since I already labeled that first point with 1s, that's the one that I used, but you could use the other point and still get the same equation in slope-intercept form. But I'm going to use this guy right here because it's already got the 1s in it. So I'm going to do y minus 2 equals the slope that I found, negative 2, x minus 1. So this is really nice. This is in point slope form, but it asks me for slope-intercept. So slope-intercept says, look what form you need to do, distribute if necessary. We definitely need to distribute. There's no parentheses in slope-intercept. So my y minus 2 stays the same. Negative 2 times x is negative 2x. Negative 2 times negative 1 is a plus 2. This one's easier than standard form, I think, right? Because if we just need to get the y by itself, that means all I have to do is get rid of this minus 2. That's the only thing sitting with the y. So that means I'm going to have to plus 2 and plus 2. Those guys cross out. So y equals a negative 2x plus 4. So there is my slope-intercept form. I had to find slope. I had to use one of those 2 points. So this is a sneaky problem because we have to find, you could graph it and count rise over run. You can do whatever you need to do to find that slope. Right? Last but not least, let's talk about one other thing. This problem is just like that last one. More sneaky problems. X and Y intercepts are coordinates on the graph. If you look at problem number 6, it says write an equation in standard form for a line that passes through the x-intercept 4 and a slope of -3. Well, x-intercept 4, we're not going to do this problem, but let's just figure out what that coordinate is. If I've got an x-intercept, 1, 2, 3, 4, right there, right, that's my x-intercept. What is the ordered pair for that x-intercept? Notice, remember when we did the test and we said when you find the x-intercept, you put a 0 in for y? Notice my y-coordinate in that ordered pair. It's 0. So that's an ordered pair. So now we could do problem number 6 because I tell you the m and I tell you a point. So we could go ahead and do that. Number 7, same thing. Let's just figure out what we've got here. We're not going to do the problem because I think that we can finish that up. It says write a point-slope equation of a line that has an x-intercept of 4 and a y-intercept of -2. Well, we just talked about that x-intercept of 4, right? 1, 2, 3, 4. Y-intercept of -2. Both of those are ordered pairs. My ordered pair is not 4, -2. My x-intercept ordered pair is going to be over 4, up 0. My y-intercept ordered pair is over 0, down 2. Notice when we find the y-intercept, my x value is 0. So now if I've got 2 ordered pairs, do you know how to find the slope? You could count it since we got a little graph sketched, or you could use the slope formula. Now you can use one of your 2 points, x1, y1, or x2, y2, and I would probably ask you to write this in SlopeIntercept. I got to be honest with you, my go-to is to write in SlopeIntercept. I don't actually usually use Pointslope except to find the other 2. So here's your job. What are the 3 forms of an equation of a line that you can write a linear equation? So tell me all 3. What is it called and what is the equation for it? In your practice problem, I give you this equation, y minus 5 equals 1/2 and an x plus 6 in parentheses. Write that in slope-intercept form. I probably shouldn't write this down because you need to know that for the last question. And write that in standard form. So that if we do that, we'll have all 3 forms of those equations. That is it for section 4.2. We'll see you next time. Have a good one.